from 0.2 millimeter to 2 millimeter. And when under the category, under the grouping based on field, it is just coarse. It's not very coarse, just like what we have in the gravel. Then we have the fine sand, which is 0.2 millimeter to 0.02 millimeter. That is ranging from 0.02 millimeter to 0.2 millimeter. It is slightly coarse. It is not that too coarse to field. Then we have the silt, which is smaller to that of sand, and coarse sand. And the particle size ranges from 0.002 millimeter to 0.02. So that is the particle size is small. That is, the diameter of the particle size is smaller compared to that of sand, but larger than that of clay. If we now check the grouping based on field, we see that of silt is smooth to touch. That is, if you put it on, if you rub it between your fingers, you see that it is smooth. Then we have clay. The clay is has a particle size less than 0.002 millimeter. Once the particle size of your soil is less than 0.002 millimeter, then we know that this is clay. That's the property of the diameter size, characteristic size of clay. And then if you now check the feeling, it is sticky. It is sticky to touch. It is sticky in feel. And then we now be looking at the physical properties of sand and clay. Clay, under the clay column, we have clay is very small. Clay has a very small particle, which is unlike sand, which has a large particles. Then the other difference is that clay forms aggregates, while sand has no structure. Then the third one is that the third property of clay is that it has high water holding capacity, while for sand it has low water holding capacity. Under clay again, the property of clay is that it has small pores. That is due to the fact that the particle size are very small, and they are interwoven. It can be closely packed. The pores are very small. That is, clay has small pores, while sand has large pores. That is, pore spaces. That is the spaces in between each particle. That's what we refer to as pores. Pore spaces are spaces in between particles. And since the particles of clay are small, then the spore space, that is interparticle space, will be relatively small, which is unlike sand, which has large particle size. Due to that large particle size, and we know that the particles does not have regular shape. Due to the fact that they don't have regular shape, the pore space will be large, which is unlike the small pores, that is the pore spaces that we have in clay. Then the fifth property of clay is that it swells when wet, and then it cakes, that is, it cracks when dry. But for sand, it is not affected by wetting and drying at all. It's not being affected by wetting and drying. If you pour your water, you have your water, and then it does not have water retaining capacity at all. Then the sixth property of clay is that it is difficult to cultivate, while for sand it is easy to cultivate because it is not sticky. Then we now look at the chemical properties of clay and sandy soil. For clay, the chemical property is that it consists of many minerals, while for sand consists mainly of silicon oxide, just like what we have in cats. Then the second property of clay is that it is rich in plant nutrients, while for sand it is poor in plant nutrients. For clay again, that is the third chemical properties, it has good mineral holding capacity, while for sand it has poor mineral holding capacity. capacity. For clay again, which is the last one, the chemical properties that we're having, it shows it is slow in the composition of organic matter, while in sand there's fast in the composition of organic matter due to the fact that the insects can burrow in a sandy soil easily, and then the pore spaces are high, which is the activities of burrowing agents like insects and earthworm. Now our next subtopic is chemical and biological composition of soil. That is what the chemical and then what makes up our soil. The soil is made up of 5 components, namely the soil macro and micro nutrients. Then the B part is the second one is the soil water, the third one is the soil air, and the fourth one is the soil microbes, while the last one is the macroorganisms. Then we'll look at how the explanation of each, that is how each makes up our soil. Soil, macro, and micronutrients. These are elements which makes up the nutrients required by plants and can be divided into 2 groups, which is based on the quantity required by the plants. Based on what we have there, we said soil macro and micronutrients. And those that are required in large quantities are called macronutrients. That is, nutrients that are required in large quantity are being referred to as macronutrients, such as nitrogen, phosphorus, potassium, calcium, magnesium, and sulfur. All these elements, all these minerals are required in large quantity, while those required in small quantities are referred to as micro elements. That is, once we say micro means small, indivisible, very, very small, such as iron, manganese, copper, zinc, boron, and chlorine. These are all micronutrients. That is, the plant requires them in small quantities. All these elements must be present in the soil in sufficient quantity if plants are to grow and develop adequately or optimally. Now we'll be looking at the next components of soil, which is soil water. Soil water is also referred to as soil solution, which is obtained from either from rainfall or irrigation. That is the artificial application of water on the soil or the rain. It is usually found in the soil within the pore spaces, that is the spaces between the particles of the soil. When water is too much in the soil is said to be waterlogged. A waterlogged soil can be improved by constructing drainage. That is, the drainage assists in removing excess water from the soil, so as to make the soil suitable for more crop cultivation. While if there is inadequate soil water, in a situation where there is inadequate soil water, this will result in wilting or eventual death of the crops, and this can be corrected through irrigation or rainfall on the soil. Soil water acts as solvents, which dissolves minerals so that they can be made available to plants. It also acts as carrier for plants' nutrients. That is, once the root absorbs the water, takes in the water, it is the water that will carry the nutrients to all the parts of the plant where they are being needed. The nutrients won't just enter the plant, they enter in form of solution. That is soil solution. They enter through the water into the plants. That means the water is a carrier of plant nutrient. Then the next composition of air, that is the next component of soil, is our soil air. The soil air refers to the gases present in the soil pores found between the soil particles. That is, our soil pores, if you could recollect from my past explanation, I said The soil pores are the spaces between soil particles. The amount of soil here depends on the amount of pore spaces. It depends on the amount of pore spaces and then the amount of water in those pore spaces. If the pore spaces are being filled completely with water, then there won't be air in the soil. But once the water gets drained to an optimal level, then we now have both air and water within the pore space. And this also depends on the type of soil. Just like in clay where the pore space is very small, then we should expect that the soil air will be very small, which is unlike in the sandy soil where the pore space is very high, is very large, and the soil water also, the pore spaces is not being filled up with water, then the soil air in such soil will be very high. The ability of air to circulate freely in the soil is called soil aeration. That is, soil air. Is anything aeration, that means the movement of air. Now, when we now say soil aeration, that means the ability of air to circulate, move freely in the soil.